Okay, this lesson we're going to be looking at renewable energy. It's a little project I started a few years ago, but I haven't really decided whether I should continue with it yet. It's to do with getting energy from waves, and I spent about 25 years sailing on ships, and I've been in quite a few storms like this, and I just know the power of the sea, and it just seems a little bit of a pity that we haven't really found a way of harnessing that energy. So we're going to be talking about how to harness that energy, and especially the idea which I came up with, which I thought was quite an original idea. When I first thought about how to get energy from the sea, initially I came up with this idea, and what it is, it's a wave energy generator, and I've actually put it inside a 40-foot container, and I was thinking that a ship could maybe carry 100 of these wave energy generators, and that would produce quite a lot of electricity. Anyway, after I did the calculations, I found out how little energy it produced, and so I couldn't use this method for producing energy from the sea. So I had to come up with another idea. But let's just have a quick look at this idea here a little bit first. And I think you'll be surprised how little energy could be created from this machine. Anyway, what I want you to notice is here. I want you to notice how the wave energy generator, which is inside this container frame, how it's being supported by the container frame itself. Okay, so now I've taken away part of the frame so that we can actually have a look at the wave energy generator inside the container frame. Basically what it's made up of is a very, very heavy semi-drum, container in the shape of a cylinder. It's filled with sand, and that makes it very heavy. Because this container is actually on a ship, so the container will be rolling as well, but the actual steel drum, or this steel cylinder, it will try and stay in the same position, and the actual container will move around it. So this rolling movement, it'll be circular, because if you are standing on the ship, it would look like that this orange semi-cylinder here would be swinging from side to side. As it swings, the movement is caught by this hydraulic rotary pump here. And this hydraulic rotary pump, when it catches the movement, it causes the oil inside the pump to become compressed, right, and become pressurized. And when it becomes pressurized, it will travel along these blue hydraulic pipes here, and it will turn a hydraulic motor. And the hydraulic motor will turn this flywheel, and the flywheel is only there so that the energy will be constant when it is delivered to the generator. So let me just repeat that again. If you're standing on the ship, it will look like this steel semi-cylinder filled with sand will rock from side to side. The semi-rotary pump will pick up this rocking motion and convert that rocking motion energy into pressure, and that pressure will be transported by oil along these hydraulic pumps to a hydraulic motor, and the hydraulic motor will turn the flywheel, and the flywheel will turn the generator, and the generator will create electricity. On both ends of the container there are rotary pumps. You can see these pipes. This pipe here will deliver the pressure created from this rotary pump at this end of the container, and that will deliver the pressure to the hydraulic motor as well. So both rotary pumps will be delivering pressure to the hydraulic motor. So this is a better diagram. You can see more clearly hydraulic pump, hydraulic motor, flywheel here, and generator to produce electricity. Okay, let's have a quick look at the calculation we need to do to find out how much power this machine can create. So what I want you to imagine is that this picture here is a cross section of the semi-cylinder. Now if you were standing on the ship, as the ship rolled, it would look like that the cylinder was moving. So to calculate roughly how much energy we could create from this, we need to calculate what the potential energy is. And the potential energy when the cylinder moves, when the center of gravity of this cylinder moves from G1 to G2, to calculate that we would need to calculate the height. And then after we've calculated the height, we need to calculate how heavy the cylinder is, and that will give us how much potential energy we could get from this device. There is a little bit of inertia energy to calculate as well, but that's very small. I've already done a calculation, and let's just have a quick look at the calculation I've done. Okay, so here's a picture of the semi-cylinder again, and this is the angle here. I've got Y, the angle that it's going to roll. I've said that the angle of roll is going to be about 20 degrees, and I've said that the roll period is going to be 7 seconds, so I need to half that because this cylinder is going to go up on the left, or up to the left and up to the right as well, within one roll. So, as I said before, I need to calculate the potential energy and the inertia energy, but really the inertia energy is so little I really don't need to take it into account at all. So the potential energy here I calculated as 18 kilowatts, yes, and I did the calculations for the inertia energy as well, but even after I add the inertia energy on, I still only got about 18 kilowatts. Yeah. Now, how much is 18 kilowatts is probably a bit hard for you to imagine what 18 kilowatts is. So I want you to imagine there are 7 kettles switched on, boiling water, and that's 18 kilowatts. The other thing we need to take into account is this is the maximum power I've calculated from one container. It's very unlikely we would get that sort of power. You know, I mean, sometimes it's not windy and so there are no waves, etc. Yeah. Okay, but let's keep with this figure 18 kilowatts for a while, and let's say the ship has 100 of these container generators on board, 1.8 megawatts of energy. So let's look at 1.8 megawatts of energy. How much is 1.8 megawatts of energy? Well, I guess the average wind turbine today produces 2 megawatts. So, you know, we're producing about as much as one wind turbine. So that's, you know, like 100 of these container generators on a ship, and the ship's rolling 20 degrees, which is pretty unlikely, right? And then we'd get nearly 2 megawatts. It's like for all those containers and, you know, for all that trouble, yeah, it doesn't really sound like a huge amount of energy. Okay, so next lesson we'll look at wave energy again, and I took this idea a step further and I made another wave energy generator, which is quite a lot better. So see you next lesson.